Welcome back to Miss Burkhart's math class. Make sure you have your notes, something to write with, and be sure to pause the video. You probably need to in this one more often than usual to make sure you are keeping up with the notes. There's a lot to write, a lot to draw. And of course, make sure you're going back and rewinding any parts that didn't quite make sense that you need to hear again. Okay? And today we are going to talk about Standard 613, solving one-step linear equations in one variable, including practical problems that require the solution of a one-step linear equation in one variable. But today, we are going to focus on how to solve one-step adding and subtracting equations using models and then being able to write it algebraically or using the algorithm. So, let's get started. In solving equations, remember we have to think of equations like a balance, like a scale that you may have seen and done things with in elementary school in science. So here's an example of a scale, and remember, it's like you're weighing objects to see how much something weighed. And when it was like this, when it was sort of even like this, you knew that what was on one side of the scale had the same weight, or same value, as what was on the other side. If it looked like either of these two on the bottom, then it wasn't the same, right? It was not equal. An equation is just like a scale in the regards that the equal sign is like the stem of the scale. And it separates the equation into two sides, the left side of the equal sign and the right side, just like a scale. So in this case, what's on one side of the equal sign of the equation, 10, is balanced with what's on the other side, 6 plus 4. Even though they're different numbers, they do have the same value, right? Just like a balanced scale. And it doesn't matter which one has more numbers on the other side, as long as what's on the left side has the same value as what's on the right side. Now we're going to use that concept to help us solve equations. Now when I say solving equations, what does that mean? In equations that you notice we have a variable. In this case, it's an x, could be any letter, but the variable is the unknown number. It's the value we don't know. Now, you might know, hopefully we'll know, the answer to this one, right? I chose an equation that you would probably know the answer to, just so you could also check yourself as you're working through it. But the objective here is for you to learn how to go about the steps to solve for the variable, to figure out what the variable is. So let's take a look at this example here. We have x plus 2 is equal to 5. And I've modeled it for you. If we look at our key, the longer rectangle is going to represent our x, our unknown. The unshaded square represents a positive one, and the red shaded square represents a negative one. Now, this is how you want to pause, and you will want to write this and draw this on your notes as well. So if you want to pause it right now and then draw these different models on your paper, that'd be a great idea. All right, so hopefully you have this written down now. And again, our objective is to figure out what x is equal to. We don't know. So here, like I said, we're going to learn the steps, the process to figure out what x is, so that when you have problems that you can't just figure out in your head, you'll at least have the steps to know to be able to figure it out, okay? So here we have x plus 2. Now, imagine that we have a scale again, and we're trying to figure out how much this, let's just call x, weighs. I don't want to know, let's say it was an apple. I want to know how much the apple weighed. Well, I'm not going to put an apple and 2 lemons on one side of the scale to then figure out, put the weight on the other sides to figure out how much the apple weighs, right? I would want the apple all by itself on that side of the scale, on that side of the balance. So essentially I want to, what's called isolate the variable. Think about what isolate means, get it by itself. So I want to isolate the variable, meaning what do I need to get rid of so that the x is by itself? I need to get rid of these two positives. So how can I get rid of these two positives? One way is I can just simply take them away, right? Take away the two positives. Now, if I do that, it's no longer balanced, right? Because before it was balanced, and now I've taken something off, so it's no longer balanced. So I have to do To keep it balanced, I have to do the exact same thing to the other side. All right? Exact same thing. So if I took 2 positives off here, I need to do the same here. Take 2 positives off. And what do I have left? X by itself is equal to 3. And isn't that what you originally thought? 3 plus 2 is equal to 5. Yes, that is a true statement. So that's one way. I could just simply subtract 2 from both sides. Now, there is another way we can solve that. To get the x by itself, add -2. Make a 0 pair to zero this out. So in that case, I would add 2 negatives. But again, if I add 2 negatives to this side, what do I have to do to the other side? Because now it's no longer balanced. I'd have to do the exact same thing to the other side. If I add 2 negatives to one side, I add 2 negatives to the other side. Now what happens is this becomes a 0 pair, right? Now on your paper, whereas before I could remove the 2 positives on my example, but on your paper you couldn't. But you'll do this, you'll circle it and draw an arrow to represent that you're taking that off of the mat. And let's look at our right side. Anything I need to clean up over here? Do you see the 2 0 pairs here? Yeah, those 2 negatives canceled out 2 of the positives on the other side. And what do we have left? We have our x, right, is equal to how many? 3, just like we thought. Okay, so now let's go over here to solving it algebraically. First thing you always want to do is draw a line down the equal sign. Yep, you got to say it that way too. And you want to put a box around your variable to isolate, to show, oh, I want to isolate the variable. I'm going to put a box around it. That also helps you see, what side is the variable on? It's on the left side. What's on the same side that I need to get rid of so that the variable is by itself? The +2. How did we get rid of the +2? We added -2. Or remember in the first time, we subtracted 2. This means the same thing. Watch, because now I did the same to the other side, to the right side of the equation. Now I'm going to draw a line. Remember in elementary school when you did this and you had problems like this, that meant equals? Same thing. It just helps keep it neat. Now I'm going to zero out this, right? Because +2 and -2 made 0. So that's just a way, you don't have to write, in fact, don't write 0 down here. You crossed it off, that meant 0. But I am going to bring down what I had left on this side, which is x. I'm going to line up the equal sign, and then 5 minus 2, or 5 plus -2, same thing, is equal to 3. There you go. Now, you probably need to pause and catch up on your notes because that was a lot to take in. So go ahead and do that now. And then when you're ready, come back. All right, so now let's just check our work to make sure it's accurate. So I'm just going to rewrite the equation here, and it was x plus 2 is equal to 5. Well, we found x to be equal to 3, so let's replace the x with 3. And we're going to say, okay, 3 plus 2, does that equal 5? Now think of this as 2 separate sides. What is 3 plus 2? That equals 5. And is that the same as what's on the right side of the equation? Yep. So we got the right value for x. Let's try another one. Now this one is going to be x minus 2. What am I going to put over here to show -2? If in our previous example it was x plus 2 and I used 2 positives. So now to show x minus 2, I'm going to use 2 negatives. So this is going to be x minus 2 is equal to, the other side of the equation, 5. Remember what we want to do, get the x by itself. So what do I have to get rid of to isolate the variable so that the variable is by itself? The -2. How am I going to get rid of the -2? I'm going to put on 2 positives. That's right. So, see if it'll cooperate with me. 2 positives. Right? Now, but what happens? We just changed it. So what do I need to do to the other side? If I added 2 positives, it's no longer balanced. I've got to balance it out and do the same thing to the other side. 2 positives over here. So do you see what we did? It was x minus 2. To get rid of the minus 2, the two negatives, I'm going to put two positives. But then I had to put two positives onto the other side as well. And now let's clean it up. And what are we going to circle? So this became 0, so I'm going to remove that. Now, do I have anything to clean up on the right side? Nope, it's just all positive. So what do we end up with? X is equal to 5 plus 2, which is 7. Now let's come over here and show how we do that written out. Draw a line down the equal sign, right? And then we're going to put a box around the X to isolate it. And so that tells us, okay, the X is on the left side. What else is on the left side? Minus 2, or the negative 2. How did we get rid of negative 2? Looking over here, we added positive 2 to both sides, to the left side, and we got to balance it out by doing it over here to the right side. Then we draw the line to say, okay, we've just added something. What do we have left? This became our 0. Cancel that out. What do we have left on the side? X is equal to, make sure you put that equal sign, and then what is 5 plus 2? 7. We got the same thing. Now let's just check it to make sure. We're going to rewrite. So initially the equation was x minus 2 is equal to 5. And then we found x to equal 7. So let's replace that x for 7. And then we have 7 minus 2. Does that, there's my question mark, does that equal 5? Well, what is 7 minus 2? Yep, that equals 5, so that side is 5. And then the other side is 5, so yep, we got the right answer. Last one we're going to do together. Well, what if the variable is on the right side? It doesn't matter. Start to think of it as two separate sides, okay? Not the answer is always over on the right side. That's not the case. So we've already got it set up for us. Negative 4 is on the left side, and x plus 3, here's our x plus 3, is on the right side. Again, we still want to isolate the variable and get the variable by itself. So what's on the same side as the variable? Plus 3. How am I going to get rid of the positive 3? I'm going to add negative 3, or you could think of it as subtracting 3. Right? But, oops, I added 3 negatives on one side. What do I have to do the other? Same thing. Add negative 3 to the other side. Make sure you're taking time if you need to. Pause the video so you can draw this in on your notes. It's extremely important you have this in your notes. All right, so now we've done that. Let's clean it up. We had our 0 pair here, right? 3 negatives canceled out the 3 positives. That was the whole point. Do I have anything to clean up over here? Nope, they're all negatives. And so what do we end up with? See, x is on the right side is equal to, and what's over on the left side? 7 negatives. So our x is equal to negative 7. Let's come over here on this side and let's write it out algebraically. Draw the line down the equal sign, put a box around your x, and that also helps you see, oh, the x is on the right side this time. What is also on the right side I need to get rid of so I can isolate the variable? The plus 3. How do we do that? We add a negative 3 to both sides, right? Draw your line. This cancels. We're just going to bring down our x. And then we had negative 4 minus 3, the same as negative 4 plus negative 3, like we did over here. And what do we get? Negative 7. And let's quickly just do a check to see that we got the right value. Rewrite the original equation. Negative 4 is equal to x plus 3. Right? And now instead of x, I'm going to replace it with what we found it to equal, which was negative 7. Right? And so negative 4, does that equal the same as negative 7 plus 3? Well, what is negative 7 plus 3? That is negative 4. So since that's negative 4 on the right side and negative 4 on the left side, we have a correct answer. Now I want you to try this one on your paper. You're going to need to draw the models using the key and then figure out what you need to get rid of. So x is by itself, draw that. And then come over here and do the same thing but algebraically. All right, so you're going to write those steps as well and make sure you check it. All right, let's go ahead and pause the video. And when you're done, Answer the questions and watch all the way to the end. So in today's lesson, you learned how to solve one-step adding and subtracting equations using models, as well as using the algorithm, using it algebraically. So great job today. Make sure you have your notes. Make sure you, if you need to, go back and fill them in. There was a lot to draw, a lot of steps to write. So make sure your notes are completely filled in, and make sure you keep it in your binder and bring it to class, and I'll see you next time. Bye-bye.